Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. Um, this is a fairly simple question. I think the student might be a little intimidated by the word problem here. Normally, a rocket doesn't travel in a straight path, but because this rocket is particularly powerful, I suppose, it is traveling in a straight path at a certain angle. So it's actually moving rising at a certain angle, which is 0.65 radians. And so we have this kind of thing, and this is 0.65 radians. I'll put an R here instead of a circle that would indicate degrees. And then we have this right triangle here. And so here's our angle, 0.65, and we're in the first quadrant here. If we want to know the slope is the same as the tangent. Of 0.65 radians. Because tangent is just rise over run. It's opposite over adjacent. You see that's the rise, the opposite. And then the adjacent, which is run, rise over run, is tangent. And so we just have to make sure, I'm going to make sure my calculator is set in radians. And now I'm going to look up the tangent of 0.65 radians. I'm getting 0.76. So that would be the slope. So that's pretty easy. So that's part A here. That's A here. And this is part B here. So part B now, if the rocket has traveled 1,000 yards horizontally, so that's 1,000 there, what's the height? This is just a straightforward SohCahToa thing. You have the tangent is opposite over adjacent, so the tangent of 0.65, which we found earlier, is 0.76. And that's equal to opposite, which would be the height of the rocket divided by 1,000, which is the adjacent. So you multiply by 1,000, and h is going to be 760 yards high. So this would be 760. That seems reasonable. See, this is pi over 2 radians here, so which is 90 degrees, so that'd be 1.5. So this is roughly half of that. So it's roughly a 45-degree angle. And you can see this is roughly, these two values are roughly the same, approximately the same, to give us enough confidence that this is the right answer. So that's all there is to it. I think it's just a reading thing where you're not sure how to set this up. The main thing is draw a diagram. Whenever you're doing trigonometry, which is what this is, you should always be drawing a diagram, in my opinion. Okay? So I hope this helps you, and I'll see you again next time. Bye-bye.